First question is, tube A has both ends open, while the tube B has one end closed, otherwise they are identical. So two tubes are given. One is tube A, which is open at both ends, so it is the open pipe. While the tube B is given having the one end closed, so it is the case of closed pipe. The ratio of the fundamental frequencies of tube A and tube B is the fundamental frequency of tube A, because tube A is a open pipe. So at open pipe, we have already discussed that antinodes are formed, and between two antinodes there will be a node. So this distance is effectively lambda by 2. Therefore, we can say in open pipe lambda by 2 will be equal to L if L is the length of the tube. So wavelength is 2L and frequency is V by lambda, that is equal to V by 2L. So we can say that for tube of length L, fundamental frequency of tube A, which is open, is V by 2L, where V is the speed of the wave. Similarly, in tube B, which is a closed pipe, at open end antinode is formed and at closed end node is formed, and the fundamental case is having one node and one antinode, and this distance is lambda by 4 for the closed pipe, and L is the length of the pipe. So in this case we can write lambda by 4 is equal to L, or lambda equal to 4L, and frequency equal to V by lambda, that is equal to V by 4L, and this is the fundamental frequency of the closed pipe. So for closed pipe, which is tube B, will be equal to V by 4L. Speed will be same because they have the same media, that is air. Therefore, the ratio of fundamental frequency of tube A and tube B will be equal to V by 2L and V by 4L. Because V by L is common, so we can write it as 1 by 2, 1 by 4. And on multiplying by 4 on both the terms of the ratio, we will have 2:1. So ratio of the fundamental frequencies of A and B is 2:1. This is the answer. Second question is, a closed pipe is excited to support third overtone. It is found that air in the pipe has number of the nodes we have to find and the number of antinodes. So as per question, we know that for closed pipe, frequencies are in the ratio of 1s to 3s to 5s to 7 and so on. This frequency F1 is called the fundamental frequency, or we can say it is first harmonic. F2 is called the first overtone. F3 is second overtone, and F4 is third overtone. So in question we are given third overtone. So we are referring here the frequency F4, which is the 7 times of the fundamental frequency, which is V by 4L. Therefore, wavelength in this case will be equal to V by F4, that is equal to 4L by 7. This implies that L, which is the length of the tube, will be equal to 7 times of lambda 4 by 4. And we can further write it as lambda 4 by 4 plus 3 into lambda 2 by 2. This is equal to, this lambda by 4 shows the distance between two successive nodes and antinodes, while the lambda 4 by 2 have the distance between two successive nodes or between two successive antinodes. So if we draw the closed pipe, then at open end there will be always an antinode, and at closed end there is a node, and in between there is a distance of lambda 4 by 4 between the successive node and antinode, So this distance is lambda by 4, lambda 4 by 4. Then there are the three segments of lambda 4 by 2. That means there are three segments of nodes. So this distance is lambda 4 by 2. It is also lambda 4 by 2. And this distance is also lambda 4 by 2. And we can make it diagram in like this. So node, this is also node, this is node. In between, where amplitude is maximum is antinode. Now if we check the number of nodes and antinodes, there are 1, 2, 3, 4, 4 antinodes and 4 nodes. So answer is pipe has 4 nodes and 4 antinodes. This is the answer. Third question is a cylindrical tube open at both ends has frequency f in the air. This is the cylindrical tube given and suppose its length is L and it has open at both ends. So for open tube, we know the frequency is given by fundamental frequency is V by 2L. If we make the diagram, open end has antinodes and between two antinodes there is a node and wave setup is like shown figure. Now the tube is dipped vertically into the water so that half of its length is in water. Therefore this is the open tube and now it is dipped in water so that its half length is under the water. Therefore this end which is having the water surface act as the closed end and another other end is open. Therefore this tube act as a closed tube. And for closed tube we know the frequency is fundamental frequency is V by 4 L dash if length of the tube is L dash. Here length of the tube is now effectively lambda L by 2. So therefore it is V by 4 into L by 2 or we can write it as V by 2L. And V by 2L is the fundamental frequency of the original tube, so we can write it as F. Therefore the frequency of the tube after dipping into the water up to the half length will be equal to the original frequency F. This is the answer. Fourth question is the fundamental frequency is in an open pipe is equal to the third harmonic in closed pipe. For open pipe, fundamental frequency is V by 2L. In closed pipe, third harmonic, it is the 3 times of the fundamental frequency and it will be equal to 3 into closed pipe fundamental frequency is V by 4L if L is the length of the tube. Suppose for closed pipe we take the length of the tube L dash, so we will write it as 3 into V by 4L dash. And as per question, these frequencies are equal. Therefore, V by 2L equal to 3 into V by 4L dash. This V and V get cancelled. It is equal to 1 by 2L equal to 3 into 3 by 4L dash. And as per question, if the length of the closed tube is 20 centimeter, the length of the closed tube is L dash, it is 20 centimeter given. So we have to find the length of the open pipe. So that means we have to find L. So L will be equal to 4L dash by 2 into 3. And substituting the value of L dash, this is 20 centimeter, it becomes 80 by 6 centimeter or 40 by 3 centimeter, 13.33 centimeter. This is the answer. Next question is the fundamental frequency of closed pipe of length 20 centimeter is equal to the second overtone of the organ pipe open at both ends. One of the pipe is given closed pipe and another is given the open pipe. The fundamental frequency of the closed pipe is V by 4L and length is given 20 centimeter. That means frequency is V by 4 into 20. This is the equation number 1. And the second overtone of the open organ pipe is, we know that for open pipe, frequencies are F1 in ratios to F2 and ratios to F3 and so on equal to 1s to 2s to 3 and so on. with fundamental frequency F1 equal to V by 2 L dash if L dash is the length of the open pipe. This is the fundamental frequency. F2 is first overtone and F3 is second overtone. This implies that the question refers this F3. So F3 is equal to 3 times of the fundamental frequency, which is V by 2 L dash. Now we have to find the L dash, that is the length of the open pipe. As per question, this F and F3 are equal. So V by 4 into 20 is equal to 3 into V by 2 L dash. V and V get cancelled. Similarly, 2 can also be cancelled here. It is 10. So L will be equal to 3 into 4 into 10. That is equal to 120 centimeter. This is the answer.